Hey everyone, welcome to another day of Global Hack Week. I know that you've been seeing plenty of me today. It's also Sunday and it's day 3 for Global Hack Week. For today, I have a special stream prepared. I changed a bit of the content that we were going to be seeing because I saw that yesterday's stream where were building a rack system was really popular. So I wanted us to finish that project today, also give a summary of what we saw on the past stream in case that you missed it, and we can get to finish our project. So I also have different things that I want to do today. I want to change things. So I know that the name of the stream is Building a Recommendation System Part 1. And yes, we're going to be finishing a recommendation system that we started creating yesterday. Because yesterday we basically saw all of the technical concepts about embeddings, vectors, vector databases, RAG system, and how the whole pipeline works. And now we started creating our methods in Python. So we created 2 different methods, one to ingest data into our vector database. And the second method was to do our retrieval in the RAG system that we were building. So I have a GitHub repo prepared for you all with all of the info that you need to have. I will be sharing that briefly after we introduce everything. So you can see the code that we had yesterday and you can have your whole environment set up. I'm going to give you also a couple minutes to check the code and to just build your own project so you can also have it. And then we will start creating the dashboard so we can do the retrieval of the responses and then actually test it out. Then what we're gonna do, and let me start popping these up. Then the next thing that we're gonna do is that after we make our project work properly, I'm gonna deploy my project and then I will share it with all of you, and then you will get to test it. And then I will wipe out the whole database so we can test out our recommendation system, and we will try to. So basically, everyone will submit like a introduction about themselves, and then we will see how good the rack system responds in depending on what we see on the database. And we will be using my database so we can see all of our hacker responses. We will do that at the middle of the stream, which is something that I'm really looking forward on seeing. So if you want to participate on these project and on contributing to the dashboard, please stick around so you can get to see how it finally ended. And then after we test it out and we have the and I share it with you and you do your intros in there and we test it, then we're gonna see if any hacker has recommendations for what I should do on the part 2 of the stream that will be happening on Wednesday. So if you want to give recommendations about what you want to see on the second part of this stream, feel free to drop them on the chat at any point of the stream, to be honest, so I can take it into consideration and design the material, because I haven't designed my stream that's going to be on Wednesday, which is the part 2. So if you want to see what's up there, just drop your comment about what you want to see for part 2 on Wednesday. And yeah, then that will be what we're going to be doing today. I'm also going to be accepting recommendations for the rack template that I was building on GitHub. So you can do your own pull request and we can merge it, and then you can have your open source contribution on one of my repositories. But yeah, there's plenty to do. So there's going to be a lot of building on this stream. There's not going to be so much explaining. So let's just get started. My name is Jocelyn, and I'm a coach here at Major League Hacking. Some of my fun facts are out there. I believe I introduced myself a couple of times, but you can just read the slides and see there. You can also feel free to connect with me on LinkedIn or on Instagram as well, because I always post almost daily content in there. So if you want to see that as well, feel free to follow me. And then we have a comment in here. I actually started the rack system an hour ago because I missed it yesterday and only got halfway through. So I'm happy you're finishing today. Yes, it was a really dense stream. I would say there was plenty of stuff in there. I have the slides loaded up. I'm just going to be going super quick through the slides. I'm not going to explain everything like I did yesterday. So if you had any question that was still not answered from what we were seeing yesterday, feel free to drop it on the chat so I can get through it. Okay, so as I'm mentioning, I'm using the same slides that I was using for the rack system, just because there's some important things that we need to know first before actually continuing with the project. And before I do that, I want to ask the chat about who was on the stream yesterday. And I'm going to give you a couple of seconds to tell me if you were present on the stream yesterday, that what was going on rack systems. It was yesterday, and I was also giving that one. So if you were present on my stream yesterday, just type something in the chat so I can know that. So I know how the crowd. Well, I know how the chat is. If I should go slower or if I should not repeat myself so much through the whole stream. I'm just gonna give you a second for you to pop your answers in there. Yeah, because we have a lot of things to do, and also mention the changes that I did on the actual code, because there's also some changes in there. Let me see. Okay, so there were some questions in here. I missed the last stream. All right, no worries. I missed yesterday. Great. Okay. Oh yes, I do remember you. Okay, so there are kind of half and half, so we're gonna just go quickly through some of the important slides. Yes, for sure, no worries. I'm gonna be giving the most important information, and if you have questions at any point, drop them on the chat, and I will stop by and answer them. Also, if things are not clear, feel free to watch the recording from yesterday about rack systems, where I explain everything a bit more in depth. So I'm gonna be skipping this. Let me see. Okay, so I like this diagram. Let's go with the first one. So first important concepts that you need to understand is embeddings. Embeddings is basically a numerical representation of our content in order to get a semantical response. So in here, I have this nice diagram where we have the three sentences: boys walking, girls walking, I'm studying. Then we have an embedding model that we're going to be using in the code. Then that embedding model converts into our vector embeddings. And finally, we can actually plot them into a space that is here. This is just a two-dimensional space as an example. And you can see how boy is walking and girl is walking. It's similar to one another. So this is how actually your LLM works. So you get to convert everything to embeddings, and then your model can actually interpret those numbers for you, because models are all about interpreting numbers. So this is basically the way that they do this. I was not on the live yesterday. All right, yes, no worries. We're giving just a brief explanation of everything before jumping into in the code. So this is the embedding pipeline. All right, this is straightforward. If you have any questions about this, also feel free to tell me. We also saw about tokenization. This is another important concept. This is basically transforming human text into a format that the LLM can understand. And the numbers are then used by models to actually perform the calculations. In here, we just have an example of how the tokenization is working on chunking into different sections. I don't know if you've noticed, but when you start using an LLM, it will charge you for the amount of tokens that you have and not the amount of words that you have. There's also a rough estimate that every 4 characters is equal to 1 token. So if you want to get a rough estimate of how many tokens you're going to be using, you can just divide all of your text by 4 characters, and then you should be getting a really a rough estimate. Each LLM has different costs. So depending on how many tokens are you using, is how much it's going to charge you. So that's why tokenization is important for LLMs, because it's a way of measuring. And then we have another question. Do you choose the numbers, or is that just assigned to each letter? No, you don't get to pick the numbers. There's a whole math process behind that. Personally, I don't know how it actually works. But you can check out this tool. I'm gonna send it over on the chat, where you can see how you can see how the tokens are being generated, and how the vector actually looks like. Let me just share that super quickly on the chat so you can see it. I found this other tool is similar to the one that I was showing yesterday. I think this one is just an open source repository that shows you how the tokens are being divided, and also how much it's going to cost you. And you can change different models in there, which is also really cool. Okay, so hopefully that works for you. We have another comment. Tokenization turns the strings into a tensor or vector. That will be a vector. And feel free to play around with this tool so you can see how it actually looks like. It's basically a web page where you can see, you can type a text, and then you get to see how it's being divided. It's really nice. So you can type a whole world, and then just see how it starts chunking everything. Okay. So we already saw this. This is another important slide to cover the applications of embeddings. Right now, we're going to be focusing on the one that's called recommendation system. Yesterday, we were focusing on semantic search, but today we're going to be focusing on recommendation systems. Why? Because we're going to be inputting introduction text about each other, and then we're going to type a new person on the chat, and we're going to see which person it recommends me to. So maybe I'm more likely to be friends with I don't know, X person, right? So we're gonna see that type of recommendation, and we can see how cool it gets once we start trying it. Okay, so here's we just basically saw a bit of the math that's behind. There's nothing complex about it. We just saw that complex vectors is the way that we developers think of vectors. So you can see vectors in physics like, oh, they have a magnitude and they have a direction and they can be plotted somewhere, right? But then in software, it's more like you are building a vector because you want to store things inside that vector, and it can change in size compared to an array. So that's just how they relate each other, but it's the same thing. Then another important thing that we saw is cosine similarity. This is the actual measure that's used in order to find the relationship between two vectors. Why this is for recommendation, or yeah, mostly recommendation, or also semantic search. I don't know if you've noticed that the difference between semantic search and lexical search. Like for example, if I go ahead and type in a regular database, what can you tell me which fruits are in the database? um, if it's a lexical database, it's not gonna show me the fruits. It's just gonna map the names of the exact words that I have according to how they are written. But if it's a semantic database, such as a vector database, it's gonna bring me the actual fruits. Why? Because they were embedded into there, they were converted into embeddings, and now I can actually retrieve them. I know this might be a bit blurry, but you will see the pipeline that I'm talking about, which is very important to understand if you want to build recommendation systems based off AI. Cause similarity is just one of the measures that they are out there to measure similarity between two vectors. They calculate the cosine of the angle between vectors, which represent the direction in a multidimensional space. We have the formula in there. You don't actually have to learn it. You can just learn that it outputs values between -1 and 1, depending on how similar they are to each other. That's another important fact to know. There's other different measurements that you can see, but that's basically one of them. Okay, and then this is another thing that we did yesterday on if you wanted to see how your embeddings were being created, and we were using the centers transformer model, which is completely free. So you can go ahead and feel free to check that resource as well. I'm not going to be testing it out because we are focusing on something different today, but just for you to keep it in mind. We have a question here. What is a vector? So it depends on what you're referring to. You can see vectors as the regular vector embeddings that we're having, which are related to vectors directly. You can see them represented as in math, or you can also see them represented as software developing areas. So it's a bit different on how we think of vectors, but at the end, they're just the same. Then let's move on. Okay, so I sent out that playground link in case that you want to visit it and just generate your own embedding so you can see what I'm actually referring to on converting words into their numerical representations. That's just for you to test it out in case that you want to. So if that's in case if you're a bit more visual and you want to visualize things, you can go ahead and hop on that link. Now we're going to be focusing on understanding these rack systems, which at the end are also recommendation pipelines. I'm going to be skipping these. We can see rack in simple terms in this pipeline, which is also a recommendation system, and you'll see why in a second. So in your RAG pipeline, you have different elements. So you have your user, you have a retriever, you have a data source, and then you have an LLM, and of course you will be having your response. So the user makes a query, and then your retriever goes and looks into the database, and if it finds something relevant, it will return it back and then input that into the LLM. And the LLM will receive both the query and the retrieved text that it just got from the database. And at the end, it's going to craft a nice and polished response that goes back to the user. So maybe this pipeline is still a bit rusty right now, but I'm just going to give you couple seconds to take all of this information in to see how this pipeline is going to be working. And this is a code that we were creating yesterday and that we were basically working on yesterday. I'm going to show you that code as well on the GitHub, so you can see them a bit more in depth. And I'm also going to be explaining where each section of the pipeline is happening on the code. I might also add some comments so you can see them. So that's also another thing to keep in mind. All right, and then we have another image in here in case this previous one was not very clear. So you get the user that has a prompt, and then the prompt goes into a retriever, and then the retriever searches for context and then returns it back. And then that retrieved context is inputted into LLM. And so the LLM receives two things. The LLM receives a prompt and receives context from the database. And at the end, it will craft a really nice response that goes back to the user, which is what we want to see today. This is another nice image of the pipeline on how it works. So hopefully it's a bit more clear after seeing this diagram. Also, if you have questions about how the pipeline works and how these actually relates to recommendation systems, feel free to drop any questions or comments on the chat as well. Okay, so now we're going to be seeing how does this actually connect with the chatbot that we were creating. We actually want to plug in our chatbot into a knowledge base, which can be a PDF or any source of information that we give it. And now the chatbot will answer with context from the PDF that we recently uploaded. We were using this library, so we were using OpenAI, but we changed it to Gemini, and then I changed it again to Hugging Face. I will tell you why in a second. And then we will be using MongoDB as well. Well, yesterday we were using MongoDB, so if you already have the whole setup, then good for you. And if not, I'm just going to give you a brief overview of the setup that you need to have on your MongoDB database. If you want to see the MongoDB setup more in depth, feel free to check yesterday's recording, because right now I'm just going to give a brief overview, but if you have questions, you can also drop them on the chat. The MongoDB setup is very important, by the way, because we're going to be setting up our vector index search in there, which will actually power our RAG pipeline. So this is the process followed by a RAG. I'm going to skip into the technical steps so we can see a bit more in depth. There's 5 steps into a technical RAG pipeline that works for recommendation systems. So the number 1 is that you want to understand the query that you're getting. So basically breaking down the user's question into tokens and analyze the semantic meaning. Then the second step is that you want to retrieve from your knowledge base, which in this case is MongoDB, and it is where the whole RAG interaction is hosted. The number 3 is that MongoDB does not store text, but it will store information that is called a vector, and you will see how it looks in an actual database. Number 4, the RAG will generate a similar vector for the users and see which one matches. It can retrieve top K elements, so you can ask it to retrieve, I don't know, your top 2 responses or your top 5 responses. It's up to you how many Ks you want to choose. And then at the end, the answer will be an enhanced with the context and the prompt that the user gave. And the LLM will just make everything just more polished. And you can use different models for your LLM, like OpenAI, Gemini, or DeepSeek, or any of your choice, to be honest. We have a question. Well, it's more of a comment. I got my cluster set up, but couldn't get it to connect for the test run. Another thing that happens is that you need to make sure that your cluster is accepting requests from any IP. I want to show you that troubleshooting. Maybe are you getting like an error message that says that you cannot just you couldn't reach the cluster, right? That you were getting errors when you were trying to ping the cluster. Corey, because if that's the case, then you just need to change your cluster to receive IPs from like anyone. I'm going to show you how to do that as well, in case that you want to add that configuration if it's giving you errors. Yeah, it said handshake failed. Yeah, then most probably it's that configuration that you need to do on the MongoDB side. I'm gonna get to that. No worries. If I forget to mention it, just remind me on the chat. But most probably I won't forget. Okay, so just to wrap up this technical explanation, because we're going to be moving into the code, this is another summarized version of the rack pipeline. It's a bit more technical. So you get your user that has a question, then that question goes through an embedding model. It creates a dense vector, then it performs similarity search, which is what we want to do. It goes into a database like MongoDB, and then once we want to fetch that, we get our prompt, then the prompt is passed on to the LLM, and then we finally get our output. Again, I'm going to be telling you which step is which when we are in the code, so you can identify all of those. I promise you that the code it's simple, it's very straightforward, and it's also really short. The only difference is that understanding this whole pipeline is a bit more complex than what you could have imagined on what's going on the backside. Like I believe the code is like 50 lines long, so it's really straightforward. Okay, so I'm gonna be skipping this. Okay, so we are all set. Then I'm gonna open up a new tab where I'm gonna be having my MongoDB. I'm also gonna be having my GitHub repository so we can see everything. Okay. So we're gonna be having GitHub. There we go. So let me remove this one. Now let me share another screen. Also, if you don't have a MongoDB account, please go ahead and create it for the purpose of this stream. And I have to let you know that as I'm doing everything on one computer, sometimes my screen freezes because I'm swapping too much from many tabs. So if that happens, I will just let you know. I will drop the stream for like 1 minute and then I will come back. But right now we're all good, so there's no need to worry about that. So in here I have two things open. I have my MongoDB, which I'm gonna guide you on how to like basically everything of all of the configuration that we were doing yesterday. And then I'm also gonna share with you the GitHub repository that we were using. So in the meantime, I'm just gonna give you 1 or 2 minutes to create your MongoDB account and set up the basic cluster. It will ask you to set up your basic cluster and create a basic project. Please go ahead and do so. If you have just created your account, then you should have access to the free cluster that MongoDB has. So just go ahead and activate that. Its default is called cluster 0. And then you should be seeing, once you set that up, you should be seeing a screen very similar to mine. If you have any questions about that process, please let me know. I'm gonna be here. I'm just gonna be hanging around. I will make one last GitHub commit before I share the repository that we were working on yesterday, so you can have it in there. Okay, so okay, I just made the last commit so you can see everything that I've been doing. Oh wait, did I stop sharing my screen? That was weird. Yep, I'm gonna be sharing that right now. I'm also gonna be doing a super quick project overview. So right now you can basically be creating your MongoDB account and setting up the basic cluster. Um, and I'm gonna be sharing that repository that we were working on yesterday. I just updated it because I was missing some requirements to add, but now it's all done. So this is a link. Let me pop it up in here. There we go. All right, so in here, I just made the last commit to finish the version 1 of the rack system. We're not going to be building that from scratch because we were doing that yesterday. But what we're going to be doing is that we're going to be understanding everything that's on that file. And then we're going to be plugging in these two methods into the dashboard that we're going to be building today to set up our recommendation system. So in here, there's a couple of things that we want to understand. Let me move this. So we are using LangChain, which is it's a very important library out there that's used by many developers in order to create a nice architectures for AI and LLM systems for agents mostly, so you can centralize everything and have it used in your code. If you see in here, I can use the LangChain Google Gen AI plugin. I can also use the one from MongoDB, another how do you call this, templates for prompts. And there's many things that you can do with LangChain. I would say I'm not very experienced using that library because there's just so many things and there's just so many templates that you can use. But it's there, it's the standard. You can also just skip the LangChain and go directly into using Gemini or using MongoDB. It will work the same. I'm just using this because many people have started using this library, and it's also very common to see AI applications on this library. So just so you can be aware that it exists and that is actually working. The first thing that we did yesterday is that we set up some variables. So the Mongo URI is what you will be using to connect to your database. I will show you how to get that if you still don't know where to get it. Then we created the database in MongoDB, and this is a name that I assigned to my database. Then we also created a collection, and this is the name that I assigned my collection. And then the most important part for our rack system is that we created a vector. We created an index vector search. If you don't know what indexes are in MongoDB, it's basically what makes the difference between doing an SQL query. You can see indexes as a way of not having to read the whole database in order to get a response, which will make your queries run faster. So there's different types of indexes, and for this stream, I was showing you how to create a vector index because at the end we're gonna be searching for embeddings. So that's why it's a vector index. I named my index vector index global hack week, but you were free to name it the way that you want it. Again, I'm going to show you where to get these from MongoDB in just a second. Then we created our first method, which is this one, get vector store. This one is just basically converting everything into embeddings. So yesterday we were using the Google Generative AI embeddings. We were using this model, which is embeddings 001, native from Gemini. But at the end, I had to change it because this one was only available for users that were paying for the API. And as we were using the free tier, then that would not have worked for us. So I changed it for an open source model from Hugging Face, from Center's Transformer Library, actually. This is the name of the model. I picked this one because it has the same dimension that we chose for our vector array yesterday, which was 768. If you don't know what I'm talking about, you will understand in a second once I go into MongoDB and show you how to configure your vector index search. In here, I'm just doing the vector store. I select the collection. I select the embedding that I want to input, which is this one, and the index name that I already defined over here. The other method that we created is this one. It's called ingest text. This one is just basically uploading into our database. So once that we have our document that was embedded using the vector store, then we want to add that specific document into our database. If you know a bit more about MongoDB, you would know that it stores it stores stuff as JSON objects, and those JSON objects can be called documents. So each input that I do in my MongoDB database is called a document. That is the second method. And then the last one, which is the most important one, is the RAG response. So for the RAG response, we receive a query. This query is the question that the user is going to be having. The next thing that we're going to be doing, we're going to be calling our vector store so we can convert that into embeddings. Then we're going to define our LLM that we're going to be using. In my case, well, it was everyone's case yesterday. We selected the Gemini 2.5 Flash model from Gemini because it's free and everyone can access it. We also claimed our API key. I can show you that as well. How to fetch your Gemini API key in case that you want to test this out. Or I can also send out a test key if you just want to skip the whole process. After defining the LLM, we had to define our retriever. The retriever is how many documents we're going to be fetching from our database that are relevant. In our case, we picked the top 3 elements. You can pick more than 3 if you want to have more context. So imagine that you have a really huge database and you just want to pick like the top 3 elements that are most relevant. But if you want to make your search a bit more broad, then you can select like top 5 or top 10, and you will be passing all those documents as context to your LLM. The second thing we just want to do, we just want to put in there our query. This other section is just for format. There's nothing about RAG in there. Then we craft our prompt that we're gonna be passing into our LLM, and our LLM is Gemini. So the prompt has the question and it also has the context that we're gonna be using. So it says use the following context to answer, and then it passes the whole context that it just retrieved from MongoDB, and it passes the question that the user has. In this case, our question is the one that we're going to be asking on our Streamlit dashboard. Then again, this is just format from LangChain in order to create our chain. And at the end, we're going to be returning 2 things. So we're going to be returning an answer and we're going to be returning the source. So where did we get that information from MongoDB? In natural systems, you don't actually need to tell where the information came from. I mean, you only care that you get the correct answer. But as we are trying to visualize our recommendation system a bit more, a bit better, I'm going to be adding these other parameters here in order to see which elements we actually fetched from our MongoDB database. Okay, and those were the 3 methods that we created yesterday. I would say the get RAG response is the most important one. Again, if you did not understand my explanation really well, you can also just copy paste this code or ask Copilot to explain it for you so you can be on the same page while we start developing the dashboard code. But with that, you should be up to date on what we saw yesterday and be ready to continue. Are there any questions on this RAG explanation? Because if they're not, then I will be moving on to the MongoDB setup. Okay, looks like everyone's on the same page. So if you already set up your MongoDB correctly, then there's a couple things that you need to do. So once you have your cluster created, and you should only have one because it's the free one that you should have, you're going to click on Browse Collections. And then Browse Collections is going to show you all the databases that you have. In my case, I have plenty because I use MongoDB for streams really often or for personal projects as well. But in your case, it's going to show you maybe like the default ones that are in there. What we want to do today is that you want to create a new database. I'm not going to be creating a new database because I already have one. But you want to create the database in here, like insert name here. And you also want to name your collection. Insert collection name in here. And in here, you will be adding your database name and your collection name in here. Keep in mind, remind these two, because these two are the ones that go in here. So database name in here and collection name over here. So with that, you should be having these two variables that we were talking about in just a while ago. You're gonna click on create database. I'm just gonna click on cancel because I don't wanna create a new database. All right, so with that, you should be having your database and your collection created. In my case, this is the one that I created yesterday. It's called Vector Store Database. And then my collection is named Embeddings Stream. You can have multiple collections in the same database. So that's another, and you can have multiple databases in the same cluster. These are the two, this is the collection that I created, and this is the database that I created that are over here. Okay, and then once you create your database and your collection, then you're gonna hop over in here and you're gonna go to search and vector search. This is very important because in here you're gonna create the index vector search that we need to search for our embeddings and do the actual RAG logic. In my case, I created this one yesterday that's called Vector Store Database. It reads from the embeddings stream collection, and this is the name of the index that I just created. So this is the other variable that you want to keep. Vector index global hack week, and then that's the same in here. This is the Atlas vector search variable, vector index global hack week. And we have a question in here. What did you do to create the database in your cluster? So I'll go back super quick. Let me make this. So you go to clusters, and then over here you will go into browse collections. Then it's going to connect it to your cluster, and then in here where it says create database, the big green button that's up there. Okay, hopefully that was that solves your question. Okay, and then for the index creation, this is more specific. I can't create a new one, so I'm just gonna delete one so I can show you. I'm gonna delete this one. Okay, I just deleted one because I need, there's a limit on the free cluster, so just so I can show you. So to create your search index, you're gonna go into search and vector search, and then click on this button that says create search index. So in here, instead of selecting Atlas search, you're gonna select vector search. Vector index name, you can just, this is a name that you're gonna be using on your VS Code code. So if I type vector index in here, then I will need to change the code in here to be named vector index, because that's the variable that we're talking about. So vector index, you create that, and then instead of, you will leave in here visual editor because we want to configure our index in the UI. So we're going to click on here, and you also need to select the database. In your case, you should be selecting the database and the collection that you just created. In my case, this is the one that I created, Vector Store Database. So I'm going to go ahead and click on this collection, which is called Embeddings Stream. I'm going to pause for a second so you can just have everything in. So again, this is the index name that you're going to be placing in your VS Code, and it's the name of your index. You can name it whatever you want. And then you're going to select the database and the collection that you just created, which is this one. Then you're going to go ahead and click on next. This is just the name, the path. In my case, it's embedding because I already created this. Number of dimensions is going to be 768. The reason for this is because the embedding model that we're using has a dimension of 768. This is not a number that I don't know just for memory. You can actually get it from the documentation of the model that you're going to be picking. In our case, yesterday we picked the embedding 001 model, which had a dimension of 768. But then as this was this was going to charge us, I changed it to this model, which has the same dimension. So we wouldn't have an issue when changing the dimensions on our index. Similarity method in here, you're gonna pick cosine similarity. Again, as I mentioned, there's other two that you can pick from, but today we learned cosine similarity, so you're gonna be picking cosine similarity. And that will be all. Then you will just click on next, and then you will just create in here your vector search index. I'm not gonna do it because I already created one, but yeah. And you can also click on here on view JSON. I can also send you this, so you, in case that you want to configure your vector index search from a JSON from JSON format. So it's in there in case you want to have it. Because if I send you this JSON, then you can just go ahead, and if I go back, I can click on JSON editor, and then you will just be pasting like everything in here. Like you would just do this and paste it in there. And with that, you will be configuring everything that I just said with that JSON file that with that JSON document that I shared with you. Okay, and once you create your index, it's gonna say pending, and then it will change to ready once it ended created it finished creating your index. This is the one that I created yesterday, so it's already up and running, so it should be good to go. But yeah, then I'm gonna be moving into obtaining the last element that we need, which is the Mongo URI that is stored in a secrets file. So for this one, you're gonna go head over to clusters, and then you're gonna head over to connect in here. You're gonna select drivers, which is the first option, connect to your application. And then if you scroll down, you should be getting the URI in here, which is this one. Keep in mind that you need to change these for your database username and for your database password. And now the question is, where should I get those? So to get those, and let me just send you the URI example in the chat if you want to have it. There it is. So that's the Mongo URI that you will be using, but you just have to change the database username and the database password. So to do that, you're going to go ahead and go to database and network access. And you should be seeing the base user that you have. In my case, this is my username, but I also have this other cluster with this other username. And you will be plugging in then this username, which will be different in your case because you have other username. And then to know your password, if you forgot already what your password is when you created your cluster, don't worry, you can always edit your password. You can click on here on edit password and then just type in the new password that you just want to set up. I'm not going to do it because I already have one that I created yesterday, so I'm just going to skip these. Keep in mind that once you create the new password in here, you need to scroll down and click on update user. So it will update like all of the changes for you. Okay, so I'm going to change that. I'm just going to exit. And then for the hacker that was asking about the handshake error, you can do that in this same configuration. You're gonna go into IP access list, and then in here it's gonna show you all of the IPs that your cluster can access, that can receive like requests from. In your case, you can just edit like the current one that you have, and you can just wait. I'm gonna pick this one. You can add your current IP address, or you can also select it that it will receive like requests from any IP. Like you can click on here on add IP address and then add current IP address, and then you will just, this entry is temporary, will be deleted in 6 hours, like whatever. Okay. Yes, and then with that you should be good to go. And if you just want to make it like access, like that it doesn't care about any IP, then you can set the IP to these, so it will receive requests from anything, and then you will not get that issue again. This is not a good practice method because then anyone will have access to your database. But if you're just doing a personal project and you don't mind of people like accessing your database and like running stuff in there, then you can set it up to be like 0.00, which will be accessible for everyone. Okay, so that will be for fixing that handshake error issue. Then that's basically all of the things that we need to do on MongoDB. Once you get all of your variables for the database collection and Atlas vector search and the Mongo URI, you can plug them in. You can plug them in here, so you can replace them and also have them in there. Great. So I'm just going to give you 5 minutes for you to set up your project or create your own repository, finish setting up MongoDB or whatever stuff that you need to finish by now. Because once we finish these 5 minute break, we're going to be building the dashboard where we're going to be testing the RAG methods and doing the testing with hackers, where you get to type something into my application and then we will be seeing which recommendation of hackers it's actually giving me. Great. So I'll see you in about 5 minutes. Go ahead and finish whatever you still have pending. I will also be answering questions on the chat in the meantime. All right, so I'm back. About the environment variables, you can also find a template for that. I believe I added that on the README um, in here. So in Streamlit, secrets are stored differently. Actually, this is not true. You will have two things. So you will have your Mongo URI, which has the Mongo link with your username and your password, which we just saw where to get. And then you will also be having your Google API key. To generate your Google API key, you can go to mlh.link/AI Studio. Let me go ahead and share that as well on the chat. So you will be going to this link, and then in there you will just log in. You will log in, create your account or whatever you need to do, and then you will head over into API keys, or also in here where it says get API key on the bottom side. And then you will just click in here, create API key, select your default project or create a new project, assign a name to that API, and then you will just copy your API and like use it on your secrets file. And again, this is the link for you to get your Gemini API key. Great. So now that we have everything set up and done, then I'm gonna stop sharing this screen and gonna move on into VS Code so we can do the home setup for our dashboard and call the methods that we were just basically doing. So let me remove that one, stop sharing this screen, and then I'm gonna share the other one. There we go. So in here, I have a couple of things, and sorry on why it's like a bit small. I will make it larger just once I finish explaining the setup. So if you see from the repository, this is the actual repository. I also have a virtual environment created, but that's just like extra. We have the .streamlit folder where you have your secrets. So in order to have your secrets stored, you need to create a folder that's named .streamlit and then create a file that's called secrets.toml. And then inside there, you will just store your variables as they are in the GitHub code. So you will have like um, how do I say this? Let me just create a new one so you can see. So let's say this is your secrets .toml file. You will have Gemini API key equals to, and then your key. And then you will have Mongo URI equals to, and then the name of the link in here and the Gemini API key in here. And then you will store that into your .secrets folder. The reason why I'm asking you to do this is because once we deploy our application, it will ask you to store secrets on these types of files, and it will also ask you to have a requirements.txt. This is the requirements that I have in my txt. You can also see those from our GitHub repository. Then in here we have our git ignore where I'm ignoring this folder, but for some specific reason, it's not working and it's still showing me in here. I don't know why. Oh, that's just, I don't know. Yeah, I don't know why it's not working. So I'm just not committing this file, but I'm committing like the rest of the files for you to see. Then the backend code is exactly the same as I was showing you off from the GitHub. And then what we're going to be doing today is that we're going to be doing, the home dashboard, which will be our main Streamlit dashboard. For those of you who don't know what Streamlit is basically a platform that allows, well, it's a library from Python that allows you to create cute dashboards using Python as frontend, which will sound very impressive. It is already included in the requirements, so you can also install it from there, or you can just install it running pip install Streamlit. In my case, I will be importing Streamlit, so import Streamlit as st. And then we will be referring to these to call all of the functions that we want to use. So the first thing that we want to do with Streamlit is that we want to set up a title for our page. So in Streamlit, it's very simple. You just do a Streamlit dot, and then it will show you all of the options that you can run from there. In my case, I'm gonna pick the title one because I want to have a nice big title in my whole dashboard, and I'm gonna call these rag. Well, I'm gonna call these a recommendation system with RAG pipeline. Because this is what we are basically building. We are building a recommendation system of a RAG pipeline. You can also add a subheader if you want. You can add a subheader if you want, and then you can just do a divider in here, so you can divide like everything, like the title and the subheader from your whole application. And this is just very simple. So we just have a title, we have our subheader, and then we have our divider, right? So far, so good. Let me see if there's any questions. I have a question in there. Git ignore does that sometimes. Yeah, I don't know why it's been crashing me so badly. Then we have another question saying my LangChain community .embeddings import cannot be resolved. To be honest, I was struggling with that yesterday so badly. Make sure that the LangChain import that you have is 1.1.3. If it's 0.0 something, then you need to update it or install LangChain community. So basically do pip install LangChain community, and it should be all done. And let me know if that works, because I also struggled with that, and none of the AIs was working. So I did the old fashioned thing and Google it on Stack Overflow, and it worked. So I guess sometimes that's what you have to do, because some AI models, they have these knowledge cutoff since last year, and libraries keep updating themselves. So the AI will tell you like, oh, this doesn't exist. Like LangChain does not exist in this specific method that you're trying to use, but that's just because the AI is not updated. So it's also, I would say, one of the blockers that happens when things are like really new. So yeah, that's one thing. Okay, and then the next thing that we're gonna be doing, we're gonna import our backend system. So in here, we're gonna import our backend as a RAG. So to do that, I'm gonna go back to the home, and I'm gonna do import a backend as a RAG. Because we're gonna be calling our backend, instead of calling backend, we're gonna be calling RAG. So it's simpler, and you can also understand it better. First thing that we're gonna do, we're gonna create a sidebar. So to create a sidebar in Streamlit, you will just do wheat and then st dot and then sidebar. It's very simple. And then the contents that you're gonna be adding in your sidebar are gonna be inside this small loop in here. So in my sidebar, I want to have a header. So I'm gonna have a header. And in this header is where we're going to be uploading the context of our database. So upload the context that goes into MongoDB, which will be our knowledge base. So I'm just going to place in here, upload context. Because this is the context that we're going to be storing in MongoDB that then our RAG is going to use in order to make our responses from. So we're going to upload context in there, and then the user text, we're going to create a box in here, and we're going to store that, that text into this variable. And in here, we're going to create a text area. So basically where the user can input their text. And we're going to just call it enter knowledge here. I'm just going to add an extra attribute for the height of this box. So this is just a text area, like if you're filling out a form. And I'm just going to say that the height of this text area is going to be 150. So it's a long text. So if you want to store like multiple things, then you have space, and the text area is like a bit bigger. Once you have created the text area and store that content into a user text, then we're going to create a button in order to send that information into MongoDB. So to create a button, you're just going to do st button. But in order to check that it is being pressed, you need to do an if. So if my button is pressed, so ST button is pressed, and the text that I'm gonna place in my button, it's gonna be called upload to MongoDB. So once you click that button, you will be uploading to MongoDB. And in here, we're gonna check if there is text. So if we have user text, then we're gonna create a spinner. So a spinner is a small circle that goes like round and round. So we're gonna use a spinner in order to say that we are processing like that request. So we're gonna call it like processing. And once that is done, we're gonna do rag. So we're gonna be calling our backend system, and then we're gonna call the ingest text method. And we're gonna be passing the user text that the user basically inputted into our system. So user text in here. And once that is done, we're gonna return a success message. And with a Streamlit, you do that with st success. So I'm just gonna call these done. Well, better upload it. Okay, let me see if there's any questions. On staging and staging your current changes might help with the .git ignore. I might try that. Yes, I'm gonna try that in a second once I upload this. Okay, and then once this is done, we also want to add a fall off. If we don't have text, then we're gonna spit an error message, so a warning. Please enter text. All right, and with that, you will be finishing the first section, which is basically upload the context that goes into MongoDB, and then I will commit this into my GitHub repo so you can also see it. I'm gonna upload this one and this one. So okay, I'm gonna commit this, and then I'm gonna push this so you can also have it. There we go. So now you can also see it on GitHub. Okay, I will now show you how this looks like right now, so we can test like the uploading into MongoDB. But I'm just hoping that it won't crash. So to run your application, this is so sloppy. To run your application, you want to do a Streamlit run, and then the name of the file that you want to run. In our case, our main file is hosted on home.py. So I'm just gonna do home.py and then just run this. I'm gonna also copy this in the chat so you can also test it out. So the name is Streamlit run. Streamlit run home.py. Oh, I had a banner. Too bad. There it is. Okay, this is the name. Just added it to, okay, my launching community work, just added it to the requirements file. Yay, nice to hear that. Awesome. So let me arrange my screens so I can show you like the actual output. Let me just arrange this a bit. Okay. Okay, the app is still running. So while it is still running, before I show you, we're gonna continue with the code. In the meantime, we're just gonna add another extra step in here, which is super simple. We're gonna add another header for the main chatting area. So in here is where you're going to be interacting with the chatbot that is going to be giving you the recommendations. So ask anything to the chat from our knowledge base. And our knowledge base is basically MongoDB, right? And then in here, we will be initializing initialize the whole message history, and then we're gonna display our history. And at the end, we want to handle user input. So we're going to be using one of a really cool thing about Streamlit, which is basically a chat interface. And I can show you the documentation for that. I will share that on the chat as well. Streamlit chat interface. Because Streamlit, they also run like native examples of building a basic LLM chat app. So maybe if I share that with you, it can be a bit more clear of the idea that we want to build. So I'm going to go ahead and share that with you as well. Then let me stop sharing this screen, and I will start sharing the other screen that I have in here so you can see the output. There we go. Okay, so this is how our app is looking like right now. In here, you will enter the knowledge that you want to upload to MongoDB. And then in here, we have the main title. So recommendation system with RAG pipeline, add a subheader with more explanation if you want. And then our subheader in here. And I will refresh these because I remember I added the other subheader for our chat section. So I'm just going to add this one. So now we have this other title in here. Ask anything to the chat from our knowledge base. Maybe we have too many titles. We will reduce the amount of titles because there's just so many in there. And then for the chat interface that we're going to be using, it's the link that I basically shared with you on the chat. We're going to be basically using this code that's looking like, hi. So we will be having these messages like this, and we will be also using this drop-down message to view like the whole, like the content that was retrieved from our database. So yeah, you can feel free to check these this example if you want, because it is the one that we're gonna be using in order to build our chat using this chat message to do this. All right, so now let's test if the knowledge stuff is working. So I'm gonna upload our first knowledge context that said, hi, my name is Jocelyn and I like bees. I'm gonna click on upload to MongoDB. And we are seeing the processing spinner in here that we just added. And then if everything works correctly, we should be seeing that uploaded to MongoDB. Now I'm seeing that that's taking quite a second. Let me see if there was an error on the backend. Nope, all is good. Oh, another important thing that I should mention is that the model that we're using needs to be downloaded for the first time. So the first time that you run it, it's going to take a bit of time, like it's doing for me right now, but then it's going to be faster. So I'm just going to give it a couple seconds. It looks like it was uploaded right now because it shows us the success message that we were hoping for. So now the next thing that I'm going to do is that I'm going to go to MongoDB to check this embedding that I just uploaded. So if I go to my to MongoDB dashboard, click on Browse Collections, and then look up for the content that we just created, which is vector database embeddings stream, I should be seeing this one. Hi, my name is Jocelyn and I like bees, which is the information that I just uploaded. And you can see that the embedding has a dimension of 768, which is what we were expecting. And if you expand these, you should be seeing all the embedding in here, which is an array of 768 dimensions, which are a lot of numbers. And these are the numbers that we're going to be using to do our RAG pipeline for our recommendation system. Okay, so now that we already saw how it looks like, I'm going to return to the other screen to finish the code that we were building in order to do the chat and then try out the RAG system. Then we're going to deploy it, and then we're going to see how you can test it. So let me stop sharing this one. And share this one over here. And we're gonna continue. So what we are missing in here, we are missing to incorporate that text thingy from Streamlit, which is the example that I just passed on. So what we're gonna do is that we're gonna be checking for messages. So if we have messages, I'm just gonna do tab because I'm too lazy. If the messages are not in our session state, then we're gonna create. And I'm gonna snooze Copilot so we can do the code because we still have time. And if we run out of time, then I will use Copilot. Okay, there we go. So we already initialized the message history. And then the next thing that we're gonna do is that we actually want to display that chat history. So for every message that we have in our, for every message that we have in our session state, session state dot message, then we want to display that. So with, and we're going to be using the Streamlit widget, which is the chat input. No, sorry, the chat message. We're going to call this message with the role. So again, Streamlit needs you to assign who is going to be the chatbot and who is going to be the user. So in this case, I'm just assigning the role that I want to have. And then I'm going to display the message that is going to be the content with Markdown. So message, and then we're going to assign these the content role, which is, the display of what the AI is going to be basically spitting out. So with that, we display the chat history. Then we need to handle the user input. So if we received a prompt, we're gonna be, if we received a prompt, not sure how to, let me think for a second. If we receive a prompt, no, we want to do a prompt will be equal to the chat input that we received, chat input, and we're gonna type in here inside the chat input, ask any question to the chat. So with that, we gather the prompt from the chat input, and then we're gonna do our if. So if we have information from our prompt, then we will be adding that as a chat message. So we want to add to show like the nice bar in there. So SD chat message, and this is going to be the user. So it's going to have the role of the user, and we want to show that in Markdown. So in case the AI spits something that uses Markdown, we can actually interpret that Markdown so it doesn't show us like really weird characters. So we want to convert that prompt into Markdown. And then we're going to add that into our session state. So SD session state message, and then we're just going to append that. So you use this, and then the role that we're going to be having. So this is going to be the user. Oh, I always mess up in these sections. So then I know it's going to be the content. And we're going to have in here our actual prompt. Okay, this looks nice, but I'll see if this actually works. If prompt, okay, I'll leave it like that. Okay, and then the second thing that we're gonna do inside here, all that I'm doing in here, this is just for the front end side. You don't need to worry too much. Now I'm gonna go into the actually fetching for the RAG response. So I'm going to add another comment in here, generate RAG response in here. So the first thing that we're going to do is that we're gonna store that into a message. So the response, so ST message, chat message. We want to show the assistant, which is we can call it something else like robot or whatever. That it's going to be talking. And then we also want to spin up that spinner that we used earlier, so we can see when the AI is thinking. So we show like the small loading thingy. So with the spinner, we're going to show like thinking. Not sure why I'm using caps, but I don't know. And then we will be storing our RAG response in a variable that's going to be called response data. And then we're going to call our backend system, which is RAG. So RAG and dot. And then we're going to use the method that we created on the backend, which is called get RAG response. And we're going to pass the prompt, which will be our query for the RAG. Then we're also going to store our answer. And the answer, we will get it from response data that we already created that has the name of answer. If you don't know where I'm getting these variables, we actually already declared those at the end. So we have answer and we also have the sources from our backend. So I already fetched the answer, but then I also want to show the sources where I'm getting the information from the database. So response data, and then this is going to be sources. There we go. And finally, we just need to print our response. So we're markdown. We're going to print our answer. There we go. So hopefully with that, we should be seeing the answer. I'm still pending in here to show the actual sources. So show sources. I'm going to use Copilot for this because I honestly don't know how to do it. Okay, let me do a prompt. Show sources in expander. With expander for iSource enumerate. Okay, this sounds nice. And then close the session state. Up and response, there we go. Okay, so I use Copilot for this because honestly, I didn't remember how to use the expander feature. But with this, we should be seeing the source of where it actually got the information from MongoDB. And then the last thing that we're doing is that we're just adding that message into our message history, which is basically what we did in this upper side. I'm going to commit this into GitHub so you can also see it. RAG response handling in Streamlit. Okay, and then I'm gonna push this one. There we go. So now you should be seeing the updated code on the GitHub in case that you want to give it a look. Let me then now I'm gonna stop sharing this one so we can see the output from our Streamlit dashboard. Let me share the other screen. All right, so it says that there was a file change, so I will reload these just so we can get the updated one. Let's see. So if you get it to work right now, then I can deploy these instantly from here and then get it, well, if it was working. As this session has no attribute message, did you forget to, oh, yeah, I forgot. Did I forgot to initialize our message? Let me just do that update. Maybe I forgot to create that message variable. That's why it was not showing me like anything. I will update that on my side, and then I will also commit that into GitHub, and I will just reload our file that we had in there. Where is the message? Okay. Are there any questions while I'm solving these? Any questions about like the Streamlit or the dashboard that we're building? Because we're about to hop into the other section. So hopefully you get like everything. You get everything done in there. Oh, I found a mistake. I was missing an S. Session messages. SD session state dot message. It's supposed to be messages. Yep. Okay. Let me refresh then this one to see if that was a mistake. And if it worked, then I will just upload that into GitHub. Okay, so apparently that worked. I was just missing an S. I will upload that so you can see it. Added missing S in messages. Okay, that's done. It's on GitHub now, so you should see the updated version. Let me just refresh these. Yep, it's in here. Adding missing S in message. Okay, great. Then if I were to ask, like, what is my name? A regular LLM would not be able to know what is my name because I'm just talking to it and it's like a completely brand model that I have no history with. But if you can see from my cluster, I have plenty of messages that say, my name is Jocelyn, hi, my name is Jocelyn, and I like these. So you should be able to answer that simple question. So I'm gonna send these. Oh my God. ST session state has no attribute message. Oh my God, another S that I'm missing. Um, SD session state messages. SD, that is in line 37. Let me see. Session state dot. Yep, I saw it. There we go. Let me see. Okay, I already updated all of the S that were missing. Let me just reload the page again. And try again. What is my name? It has an R because I named it the robot and now it's thinkings. The final answer is your name's Jocelyn, and then it's showing me the sources of where it got that information. Right now, we only have three sources in here, and I'm asking the rack to retrieve the top three responses. So even though this one has no context, it returned a source tree because it has the less amount of cosine similarity. So it is less likely that this is the correct answer. So the most context was obtained from this one. My name is Jocelyn, and then the other one is, hi, my name is Jocelyn, and I like these. So now let's try to ask, what is my favorite insect? It's thinking. Says, based on your statement, your favorite insect is bees. And now if we expand the sources, now my first source is, my name is Jocelyn and I like bees. All right, so it looks like it is working perfectly. I will deploy these so you can test it out and we can input a lot of knowledge in here and then we can interact with the chat and see what recommendation it gives us. So if you want to deploy your Streamlit app, I can also explain how to do that. You're just going to go and click in here where it says deploy. I'm going to pick Streamlit Community Cloud. You can also do it in Snowflake or other platforms. I'm going to pick Streamlit Community Cloud and click on deploy now. What? It's not connected to a remote. What? I already have that connected. Why is it showing? What the? Oh, okay. Now I know why it's not letting me. Because I have another folder that's maybe causing like the whole struggle. So I will do the deployment directly from Streamlit Community Cloud. So I'm gonna close these. I'm gonna go into a Streamlit Community Cloud. The reason why this is happening is because I have another folder on my folder directory instead of only the GitHub repository. So maybe that's why it's getting lost. So what I'm going to do now is that I'm going to do the regular deployment from the community cloud in here. So I'm just going to click on join. I already have an account, so I'm just going to log in there, continue to sign in. Continue with Google. I think I have it with GitHub, but never mind. Nope. Continue with GitHub. Here I have all the Streamlit apps that I have deployed, which are so many. I will just click on the create app, deploy a public app from GitHub, deploy now. I'm gonna select the repository, or I can just paste the URL. So I'm just gonna paste this URL that I have in here, rack template, and it's already telling me main branch, and the main file is called home. So that's the one that I'm gonna pick. And the app URL, I'm gonna call these rag template. Oh, recommendation. And that domain is available. Great. Then the next thing that I'm going to do, I need to add my secrets. So I'm going to click on advanced settings, and you can select the Python version, and you can also, you will need to paste your secrets in there. So I'm going to remove these so I can upload my secrets. So just go ahead and paste anything that you had on your secrets.toml file, and then just click on save. All right, so I already did that. I already added the secret, so I'm gonna click on deploy, and then it will start deploying everything for me. Hopefully we don't get any mistakes, because I was using a 3.11 Python version, and then I selected another version here. So if anything crashes, we'll just solve it, or I'll just downgrade the Python version that Streamlit is using. In here on the Manage app, you can see everything that's going on, like all of the logs that it's getting. Right now, it's just setting up, so we're just about to get started. While this is happening, I'm going to hop over into my repository. I did promise you two things. So the first thing is that if you have any recommendations about what should we add to our recommendation system on the part 2 of this stream that is happening on Wednesday, please let me know any ideas of what you would like to see on the chat. Because if there's anything in particular that you would like to learn, or anything that you would like to add to this, you can drop it in the chat so I can take it into consideration when building the content for the next stream, which will be the part 2. Happening on Wednesday, hopefully. And then the other thing is that if you want to contribute to this repository, make sure to fork these and then make a pull request. I can review it, and you will be added as a contributor on the application. So feel free to do that. I will be reviewing pull requests, tomorrow, starting Monday. So if you want to add something, or, another thing is we need to update this README, because it's not updated correctly. So you can also do a pull request to update the README, or to add more functionalities to the dashboard, maybe to use multiple LLMs in order to do the rack system, or something like that. Anything that you can imagine, you can fork it and then do the pull request. And I'm seeing that 14 people already fork it. So hopefully you are working on some really cool pull requests in there. Okay, and then using Streamlit is really cool, as it allows you to stay in Python without using HTML and such. Yes, that's why I really love it. If you want to focus more on the backend side, and start working more in depth on your application, without having much experience on the front end side, you can try Streamlit. Great, so let's see if the application was deployed correctly. So it's still mounting. Oh, there's a mistake. The app, what it says. This app has encountered an error. Backend rag and nominal name. Oh, I think I forgot to include LangChain community in my requirements. So I'm just going to add LangChain community into the requirements, and then I'm going to redeploy these. And then the backend, why is it not finding the backend? That's really bad. Honestly, okay, I know how to solve this, but I don't know how to solve this, so I'll just solve one. A second, I'm gonna push my new requirements and home. So updated requirements. There we go. Okay, and in the meantime, I can actually share this link with you so you can see the application up and running once it starts running. So yeah, it should be on this link. I will also wipe out all of the content that I have on my current cluster so we can fill it out with new content. So I'm gonna delete this, delete, and delete. So now it's ready to receive information. So I just wiped the whole knowledge base so we can start inputting like cool information in there about us. Okay, it kind of worked, but I still have an issue in here. Let me see. I think it's working, huh? Not sure. Okay. I will try it out and let's see what happened. This is just an example of what you can write, but for you, like another name. Hi, my name is Jocelyn. I do streams at Global Hack Week. I also work as a cloud developer at Insulin. Right now, I'm doing a neuroengineering research internship at the University of Houston. So this is a super specific text about myself. So this is an example of what you can upload to the MongoDB database. So we have, recommendations that we can do from. So right now my text has already been uploaded. Feel free to upload your stuff in there on MongoDB so we can have some content on what we can actually recommend. Let me refresh these so I can show my text in here. Oh, that's really cool. There's already people that's writing. Yay. So, yeah, this one I think it's repeated. That's really cool. So keep your inputs going. You can input in here. Just click on upload to MongoDB so we can get it to work. And now let's try the LangChain stuff. Um, let's type who likes Python. And it says, based on the provided context, Felipe likes Python as he identifies himself as a beginner Python developer. That is accurate. So it got it correct, and we can see the sources. So the source number 1 was this one, source number 2 is this one, and then source number 3 is mine, which has almost nothing to do. And it's really nice because you get to see how the LLM is actually crafting a really accurate response. And it's also using the markdown. If you see, this is in bold in comparison to this one. So the markdown is working perfectly. Great. So let's see if there's more questions that we can create to test our system. Let me refresh this one. Okay, so we have more in here. We have 2. Let's try a question that says who studies CS to see what it actually says. So who studies CS? Leo Newton studies CS. And yes, the source number 1 is this one. Then the source number 2 is this one, because I mentioned that I work as a cloud developer and so on. And then this one is I am who, and this is my first time using Streamlit. I don't know who you are, but yeah. That's really cool. Let's see if there's more. Let's see if we can get at least 10 inputs in there. If not, I'll just create like random inputs. Okay, I'm gonna delete one from you, Felipe, so it's not repeated. So now we have 1, 2, 3, 4, 5. Okay, let's see if we can get more inputs in there. Again, it's just entering on this web page and inputting like your message on these boxes that's in here. I'm gonna try another one saying, I don't know, I want to use my second name. My name is Anaid. I just built a Lego set of 2 cute plants while I was watching a TV series on my iPad. Load to MongoDB. Okay, that's super specific, and it was exactly what I was doing just before I connected in the stream. I was finishing like these Lego plant that I have in here. so nice. It's a Lego plant. Um, but yeah, it's a set of two. But this one I built it like earlier, so it's just like a small. Oh, there's a small plant. It's really nice. Okay, so now that I have these, let me see if there's more people, and also reload. Dun, dun, dun. Okay, so we have 9 contents now. I don't know what to. I don't know which question to ask now. Let me just ask random stuff like, um, who likes candies? I don't know if some of you placed something related to candies, but let's see. Based on the provided text, there is no information about anyone liking candies. Okay, that is accurate. And the top cake was okay. This is interesting. It also mentioned me and Leo as well. I don't know which other question to try, and which is cool plant. Yeah, it's really nice. Does anyone have any question that you would like me to ask to our recommendation system? I'll see if there's any question on the chat to do that. Because I cannot think of any other question. Who studies CS? Let me ask that again to see if there's more people. Okay, it dropped the same answer, but let's see in the sources. Okay, there's someone else. So we have Leo again, but then we also have Sadweek, which is a sophomore as well. University of Engineering and Management in India. And then there's also me, which is mentions the cloud developer and the research again. That's accurate. It errors out when I ask it a question. To mine, like to my local deployment. Or like to the one that you were running on your local deployment. Is it failing on my app? Like when you try to ask questions? Yeah, from the link. That's too bad. Can you paste the error message that you're getting on the chat so I can see it? Because that's just so weird. Not sure if it's related to this. Cannot copy. Oh, I think I'm seeing all of your errors in here. I asked a question successfully. Huh. Okay, so it's working for some of you, but not for all of you. Max Cecil Bunny, can you confirm if it was working on my link? Okay, we have train it to answer what is neuroengineering. Okay, let's try that. What is neuro? Let me close this. Neuroengineering. Wait. Let's see. Based on the provided information, Jocelyn is currently doing a neuroengineering research, blah, blah. It is however, the context does not provide a definition or explanation of what neuroengineering is. And then it brings out this one. Let's try the other answer saying, who likes nature? Let's see. Naid seems to like nature as she built a Lego set of 2 cute plants. Oh, that's really nice. And it gets this one. It also mentions me and then Leo again as well. That's really cool. The app is running on my end. Okay, now it's working. Okay, great. Then yes on your link. Okay, awesome. It said it was on line 43 when it error out. The error message disappeared. That's super sauce. All right. Okay, so I think we already tested these enough times. Thank you everyone who contributed to build our really cool data set. I believe there were about 8 or 5 hackers that were participating. Let me see if there's just more input so I can test it. Okay, there's another one in here. Ibrahim. Okay, maybe you can input a bit more context so it will show what that is. All right. I can also ask it. Who? No, maybe. Who is new to Streamlit? Let's do this last one. Based on the context, you know who is new to Streamlit. As they state, this is my first time using Streamlit. Ah, that's really nice. All right, so I will leave you with that. Remember that you can do any contribution that you would like to this repository over here. You can also let me know right now on the chat any recommendations for the part 2 of this stream that will be happening on Wednesday. If you have any idea or any comment, you can always let me know on the Discord message as well. Um, Okay. Yes, no worries. So it's always nice to help. What is your research about? It sounds really interesting. Yeah, so the research is basically about intersynchrony between brains of people that are dancing. We are focusing specifically on Balinesian dancers that are from Bali, which is a Western culture, and we are analyzing how their brain waves synchronize and how their eyes move and synchronize as well when they are dancing. So it's a really cool research paper. Hopefully, it will get published in the Nature Journal in about 2 months once it passes like all of the review sessions. But yeah, I will be sharing more updates once it happens. So that's also really cool. Again, if you really like this stream or you would like to add some feedback or if you would like to see more stuff on the following streams, feel free to drop a feedback or a rating in that link. I'm going to paste that link as well on the chat so you can have it. Emily should link Global Hack Week feedback. And yeah, it won't take you more than 3 minutes, and it's really valuable for us and also to rate everything. I will be seeing you, I believe, on Wednesday, where I will be onboarding one of our new streamers, and I will also be giving the part 2 of these recommendation systems stream. Yes, no worries. The repository is in there in case that you want to give any updates. Bye, everyone.